In this video, we're going to be talking about the difference between physical and chemical properties as well as physical and chemical changes. So we'll start off with properties. So physical properties are those that can be measured or observed without altering or destroying the sample. So some examples of what we mean by that. The simplest one is probably appearance. What does something look like? What's its color? Is it a solid, liquid, or gas? So I guess state of matter. At a particular temperature would be a property as well. Kind of goes hand in hand with what is its melting or boiling point. What is the temperature at which that thing changes state of matter? So what else did I have? The solubility of something, which means can it dissolve in something else? So for instance, sugar is soluble in water. It dissolves in water. If you put sugar in a glass of water and you stir it around for a little while, it will seemingly disappear, but what has happened is that it is dissolved into the solution. Smell is another good one. Taste would also be on this list. We're going to leave it off because you don't generally taste things in chemistry labs. Usually a terrible idea. But it would be considered a physical property as well. So all of these things don't involve destruction of your sample. If you're measuring, say, your melting or your boiling point, if you melt a solid and turn it into a liquid, you can cool it off and get it back the solid again. So you're not destroying or really permanently altering the sample in any way. Chemical properties, on the other hand, do need your sample to undergo some kind of change, because what makes a chemical property is how something reacts with something else. So how a substance reacts with other substances. Examples here being, is something flammable or not? Does something react with water? Some metals undergo a process that's commonly referred to as tarnish. Some do it more easily than others. If you've ever seen old silverware, it might have kind of a dark splotchy look to it. That's tarnish. Chemically, we call that process oxidation. And some things do it really easily, some things don't, and that is one of their chemical properties. Physical and chemical changes kind of go hand in hand with the physical and chemical properties. So a physical change is something that does not change the identity of the substance. So these are typically changes in things like size, shape, or state of matter. So some examples here would be things like water boiling. If you boil water, it turns into water vapor, but the chemical formula is still the same. It's H2O as a liquid, it's H2O as a gas. You've not changed the identity of that substance, you have only changed the state of matter. Similarly, ice melting, it's H2O as a solid, it's H2O as a liquid. You've only changed the state of matter, not the identity of that substance. It's still water. Tearing a piece of paper. You're changing the size and shape of that piece of paper, but it is still paper. Bending a spoon or a paper clip, anything like that where you're just sort of changing the size or the shape of something. Stretching a rubber band. State of matter is the one that we'll encounter most in chemistry class, and it's important, really important, to recognize that state changes are not chemical changes, that the substance itself does not change in identity, only its state of matter is changing when we undergo a process like boiling or melting or condensing or freezing. And last but not least, what we will focus most of our attention on in this course is chemical changes. So a chemical change changes the identity of one or more substances involved. So I'm not going to really give specific examples here because most of them won't be super familiar to you, but what I am going to give you is some clues that a chemical change has occurred. Because these are things we want to be on the lookout for in this class. So basically my sort of summary of how do you know if a chemical reaction happened is that something unexpected happened. So unexpected change of color is a big one that we'll encounter a lot. So what I mean by that is, say you take two clear liquids, two things that look exactly like water, and you mix them together and all of a sudden it turns pink. There's no reason you would expect that to happen if you didn't know what those two clear liquids were. If we compare that to what I would consider an expected change, would be something like if you mix a yellow liquid and a blue liquid, you would expect it to turn out green. Yellow and blue makes green. But clear plus clear does not usually make pink. So if it does make pink, that means a chemical reaction happened. So example here, mix two clear liquids. And it turns pink. A more everyday example of this is frying an egg. If you've ever fried an egg, or if you've ever seen a raw egg, you know it's pretty much clear to begin with. After you heat it up for a while, the egg white turns white. It turns completely solid. It is no longer clear and transparent. And that is because a chemical change has happened. When you're cooking the egg, you're actually causing a reaction in the proteins that causes it to go from being clear to being white. So unexpected color change is seen in that as well. Let's see, what else do we have? Unexpected change in state of matter. Let's say if you mix a solid and a liquid, and all of a sudden you start seeing bubbles. You start seeing a gas being produced. Is also something that can happen. Typically we wouldn't expect a liquid to turn to a gas unless we heated it up, but if we do this all at room temperature and we mix a solid with a liquid, sometimes gas production starts depending on what's going on. So unexpected change of matter. Sometimes you'll also mix two liquids and get a solid all of a sudden. Unexpected change in state is another one that we're going to see a lot of. Also, unexpected change in temperature is really common. So you might experience mixing two room temperature liquids and they get warmer. Or colder, can go either way, but there's no reason that would happen. Obviously, if you added a hot substance to a cold substance, you would expect the cold thing to get warmer. But if you mix two things at the same temperature and all of a sudden it starts getting hotter, that's because energy is actually being released by that chemical reaction that is causing that substance to heat up. And that is a surefire sign that a chemical change has occurred. And last but not least, some of the more exciting signs that a chemical reaction has occurred. If you mix things together and all of a sudden they start glowing, chemical reaction is happening. And perhaps everybody's favorite sign that a chemical reaction has occurred, fire. So anytime something is burning, there is a chemical change occurring. So all of these are good clues that a chemical change has happened, and we'll get to see some of these things in action very soon.